Hello everyone, welcome to Chemazon-Complete Chemistry. So in this video we are going to solve another question that was asked in December 2023 NET exam. Okay, the question is e raised to iota kx is the eigen function of the operator px. What is the eigenvalue? So before solving this question, let us first try to understand what is the eigenvalue equation. In this, what is eigenvalue, what is eigenfunction, that we have to see. So before understanding that, let us try to understand what is the meaning of a operator. So in simple maths, what are the operators that we use? Plus, minus, division and multiplication. Okay, these are the simplest operators that we study in our school. Okay, so these are what? These are called as mathematical operators. Okay, mathematical operators. And what do we apply these operators on? We apply it on numbers. Okay, similarly in quantum chemistry we use operators like integration, derivatives. These are some of the operators that we use in quantum chemistry. This is the same concept that we studied earlier. Okay, these are the operators that here instead of applying on numbers, now we apply it on some function f of x. Okay, instead of f of x, what we write here in chemistry is the wave function, because that is what we study in quantum chemistry, right? So what happens is a cap. Okay, this is the method for denoting an operator. Cap denotes what? Operator. Okay, we are applying some operator on some wave function. We are applying operator on a wave function psi. So a cap is what? It is an operator. Psi is what? Psi is some function that is, it is called as a wave function. Okay, and after applying that, if you get the same operator, okay, the condition is you should get the same operator psi, and along with that you get some value. Okay, if you get the same operator psi, then that function, a wave function, is called as a eigen function. Okay, and the value that we get, that value, only if this is an eigen function, this value is called as the eigenvalue. Okay, and the final entire equation, if I write down again, operator applied on some function psi, you get eigenvalue and the function back. This equation is called as the eigenvalue equation. Eigenvalue equation. Okay, so the question that they've given is, they've given that e raised to iota kx, this is the psi, this is the wave function, this is the eigen function of the operator px. Okay, a cap here, it is what? It is px, linear momentum operator. So they've given that it follows the eigenvalue equation, so we should get the wave function back. Okay, we will apply now. We should get the wave function back, and along with that we will get this value. So the question is, we have to find out the value of eigenvalue, that is small a. So let us now try to apply. What is the operator that is given? Linear momentum operator, that is, we know the value is minus iota h cross del by del x. And what is the wave function or function that is given? E raised to iota kx. Okay, so now let us apply this operator on the wave function. So operator is minus iota h cross del by del x. Function is e raised to iota kx. Okay, so apply this. Apply means you have to do derivative of this. Now what is the derivative of e raised to x? Here you can see there is some constant, so we write e raised to ax. Okay, so what is the derivative of e raised to x? It is e raised to, okay, derivative of e raised to x is e raised to x into, we have to do the derivative of this power as well. Okay, multiply by derivative of ax. So this is the formula that we are going to use. So minus iota h cross is constant, we'll keep as it is. Okay, derivative of e raised to iota kx will be e raised to iota kx into derivative of the power. Power is iota kx. Now, okay, this is the partial derivative. So del by del x of iota kx. So now what is the derivative of x raised to n, that we have to write down? We know that d by dx of x is 1, but how do you get that value? Derivative of x raised to n is n into x raised to n minus 1. Here n is what? 1. So derivative of x raised to 1 is what? 1 into x raised to 1 minus 1. Okay, x raised to 0, anything raised to 0 is 1. So 1 into 1 is 1. So that is how we get the derivative of x is 1. Okay, so now iota k I can take outside. So minus iota h cross into iota k into e raised to iota kx. Okay, derivative of x with respect to x, this is what? This is 1. So now we can multiply this. Here this is minus sign. So negative sign we keep as it is. Iota into iota is iota square into h cross into k into iota e raised to iota kx. What is the value of I square? It is minus 1. H cross k into e raised to iota kx. So minus into minus 1 is plus. So the answer is, okay, h cross k into e raised to iota kx. So now if you compare minus iota h cross del by del x iota e raised to iota kx. So what exactly we did? We applied this operator on the wave function. Okay, this is psi, this is a cap. Psi, did we get the wave function back? Yes, you can see we have got our wave function back, that is e raised to iota kx. So what is the eigenvalue? Eigenvalue is, this is the value of a. So what is our final answer? Our final answer is a is h cross k. So in this way we can solve the eigenvalue equation and get the value of eigen. We can get the eigenvalue. Okay, so what is the correct answer? Correct answer will be option 2. Okay, I hope you have understood what is eigenvalue equation. How do you operate it on a wave function and get the value of the eigenvalue. Thank you.